So occasionally this part of the shop out here shows up in a video, and people sometimes ask about the equipment that's in the background. Specifically, why do you have this giant pick-and-place machine? I set this all up for doing custom electronic stuff. I was building electronics for haunted attractions, amusement parks, and over the last few years, supply became a real problem. We couldn't get a hold of parts, kind of lost the entire interest of doing this stuff, and I was just focusing on the carnival rides. But one of my longtime customers came to me and said, hey, we need some stuff. What do you think about firing up the shop? And I decided, we'll give it a try. And now we got to get these things turned out. So I'm going to fire up all the machines. Hopefully they're still working. It's a whole process here, and I'm going to show you what that's all about. Let's turn this on and hopefully it comes up. This CNC machine had been in a fire. I purchased it for $50, and I spent about a year and a half restoring it to its current condition. This was one of the very first major projects on this channel. Today we're going to be putting together what we call the foreplay. It's a 4-channel control box with built-in audio that they'll use throughout the park in various places for their Halloween event. So this little fixture holds all the pieces right where I need them. And it was left on here from the last time I used this machine. So hopefully we don't have to do too much. The first step of the process will be using this CNC machine to cut a number of holes in the boxes. These will be used for switches, connectors, and an LCD display. That's what it's going to look like. All right, let's load it up and do 9 more. All right, well that's running over there. We'll get the pick-and-place machine fired up. This is just a warm-up routine. It runs for about 10 minutes. All right, this stencil is the next step of the process. This is a stainless steel stencil that has been laser cut, and the openings match the pads that are on the circuit board. And then we put this in here. We use a paste solder, which is just little microscopic balls of solder suspended in a liquid flux. Use a stainless steel squeegee. This workshop wasn't created overnight. I've collected all this stuff over the course of about 20 years. Even this pick-and-place machine, I got this about 10 years ago on a really good deal on eBay. And even 10 years ago, this thing was completely outdated, but it's been a real tank, and it just keeps going along. There's a lot of things it can't do, but for my uses, it gets the job done. So the operating system that this machine uses is really old, and I'm not sure of this, but I would not be surprised if this is the last one of these running. It was a lot of figuring out to try to figure out how this machine actually works. All right, I'm going to go take our circuit board that we put the solder paste on and stick it in the end of the conveyor. It's going to feed in automatically and start placing components. Some of these feeders are a little bit sluggish sometimes when it first starts. This is running about a third of the speed it's capable of. I don't run it any faster because it's on a wooden floor and it vibrates too much. If this was sitting on concrete, it could go much faster. So these are the feeders that hold the electronic components, and all the components are on these reels on a paper or plastic tape. And a reel this size with small resistors can hold about 4,000 or 5,000 components on this one reel. Every time this button is pressed once, it advances the tape and exposes a new component to the head to be picked up. And it comes out of the conveyor at the other end. Now this machine is not capable of putting the larger chips on, so all those get loaded by hand. But this saves me so much time. Alright, we'll do another one. We just stick it in here. Bye-bye. This set of drawers under my bench was actually an old Radio Shack parts drawer that I picked up. I've got all my most commonly used tools in the top drawer. Next drawer down is all the different circuit boards that I built. And then these are some of the parts that we hand load. Some of the oddly shaped parts that the pick and place machine just isn't good at handling. Like these small pieces here, these are crystals. We could put those on with the pick and place machine, but the machine fumbles on these quite a lot and doesn't pick them up right from the tape, so it ends up dropping them. The crystals are fairly expensive compared to the other components the pick and place machine loads, so it just makes more sense for me to hand load them rather than losing money every time it drops one. And then things like, this is a headphone jack. It's too big for the machine to pick up. These are all the parts, so I'm going to pull the parts that I need now to do the next phase of this board. These parts here are way too big for the machine. I have some more parts that are kept in these containers. Containers are full of desiccant. These parts are also hand loaded, but these parts are moisture sensitive. You got to keep them in the desiccant to keep them dry. Now the parts that are moisture sensitive, they arrive in these vacuum packed bags, and we need to open one of these here to get a few more out. Alright, I've got the board under the magnifying glass here, and while it's here I just go through and I touch up the positions a little bit. If the pick and place machine didn't quite get it, I just nudge them. Sometimes you'll find what the pick and place machine has done is what they call tombstoning a piece, and that's when it has a component and it's actually standing on its end. Alright, these are all our parts we need to put on. So now we can start putting these on. You can see how slow it would be if I had to hand place all of these components. This right here is actually a 40-watt audio amplifier. That is the last of the surface mount components. There's still some components that get soldered into these through holes, but this is the last of the ones that just sit on the surface. Alright, next step of the process is to bake or reflow these boards. This is a homemade deal here, this oven. This is just a toaster oven that's been converted for this purpose. I actually have an oven that's made for doing this job, and it's bigger, it can hold more, but truthfully this oven does a better job, so that's why I use this. So we just hit reflow and that'll do its job. Right now the oven is just working on getting up to temperature.
A few minutes later.
Okay, so now it's at temperature and it's going to hold this for 10 seconds. Now it's going to start cooling. The door is going to automatically open. Alright, so this has cooled down to room temperature and we can take them out now. Take them over to the bench, look for things like solder bridges and things that shifted out of place when they were heating up. Not bad. So all the parts that are too big for the drawers, or else parts that I stock a lot of, go up in these bins on the wall. And these bins all came out of a hardware store that went out of business some years ago. My most common parts that I use are up in here, and then the stuff that gets used more rarely and kind of repair parts and things like that are stored down the line. That is a pad that the 40-watt amplifier sits on. Voltage regulator right there. And we've got this guy, which goes on the opposite side of the board. going to get all of them built to this point, and then we'll go from there. So after all the soldering is done, I run these through an ultrasonic cleaner to remove the flux. I'll run for about 5 minutes.
5 minutes later.
After the ultrasonic cleaner is done, these are taken out and rinsed with deionized water. After the rinse, I like to put these on a rack and wash them down with isopropyl alcohol. Just displaces the water and helps the evaporation happen faster. I've got this display to install. One last little bit of soldering that needs to be done because this can't go through the washer. All right, we're coming down the home stretch now. We've got all the LCDs soldered on, and the next step of the process is to get power applied to the boards and then load all the firmware into them. Turn that on. And we're drawing about 30 milliamps, which is normal. No magic smoke has popped out. So we use this little hockey puck device to program the microcontroller. And this just plugs into a programming header here. And then we go over to our computer and we hit program. And it will download the firmware into the controller. And now that that's complete, we can turn this over. And we see the first signs of life. It needs to be configured to tell it which LCD screen we have. Right now, it's not correct, but we'll do that in the next step. So we're going to go through now and just drop the firmware in all these boards, get them to this point.
20 minutes later.
All right, now that the firmware is loaded, we need to load some configuration information. So we hook it again to the computer and use a different program. So first thing we're going to do is select the logo that's going to appear, and we're going to send that down. And then we're going to set the serial number inside the controller. And then we're going to load the QR code, send that down. And we're going to go to the audio library. Going to select some audio clips. Send all these down. Write them to the controller. This part takes a while, but I think it's a worthwhile thing to do. I say most people are going to put their own sound effects in there. I've just always wanted there to be something in there when they pull this out of the box. I like the idea that they can just start using it right away. Plus, I can watch YouTube videos while this is happening. The final thing to do is to load some show data. We want to give it some configuration information. And then we can close this window. Now we will unplug it from the computer, and then we're going to power cycle it. There we go. Go into the menus. And if you want to see the instructions, you bring up the QR code. Just scan that with your phone, takes you right to the instruction manual. Exit out of here. All right, so this is ready. I will test it with a speaker and some LEDs attached to the outputs just to verify it works. But pretty much the next step for this is to go get mounted in a box. So we'll just go through and duplicate that for the rest of the order. For the next step of the process, we have to print a label on the boxes. And I use kind of a specialized device here. This is a printer that uses a UV curable ink. And one of the differences about this between this and a regular printer is it also has white ink. Normally when you're printing, the white would be the paper you're printing on. This actually has the capability of shooting out white ink. And we put the boards actually in the boxes because I'm going to print right on the connector as well as the box. It's going to do 2 passes. It's going to do all the white ink first, and then it's going to pull back, and we're going to do black ink. All right, I mentioned this is a UV Cure ink, and the head has a UV light that actually travels back and forth with it. But that UV light, I believe, is getting weak. So I always give it an extra shot with an external UV light. Next thing we're going to do is pull it back. We'll just give these a quick look here. So we need to do some black on top of that yet. So this is the same process that would normally be done with silk screening, but for the low quantities that I do, silk screening really doesn't make sense. So I could do a whole run of these and then load it with a different product, send it through the machine and print something completely different. It's all whatever file I load up on my computer. So we're doing a batch of 10 of these, so we'll do these 6 and then we'll load another 4. This is not the fastest process in the world, but again, I can load this up and walk away and go do something else. Black is starting to get a little bit fuzzy. I think my printhead is just starting to wear out and needs to be replaced. All right, we're ready for final assembly on these. First thing we got to do is find some buttons. These are the buttons which will push on the switches inside the case. So we just set them in there. So we got that. And then we peel off the protective film. Put this in. Make sure none of the buttons bind. That looks good, feels good. And then we put the case on. And we need the rails, just to give you something to mount them with. All right, one final test we're doing here, this time with headphones attached. And that works. We're going to put this in a bag, and we'll throw in one of the Powered by Hauntbot stickers. And this one is done. So we will fully check all of the rest of them. So we end up checking everything 100% multiple times to verify these are working. So this is their order complete. 12 pieces of this particular product, what we call the 4-play. And next step, I will put these all in a box. I think I'm just going to hand deliver them. I could ship them up to them, but Knoebels is only about a 2-hour drive from me, and any excuse to go visit them is always fun, and see what they got going on in their maintenance shops, and maybe see the status of their rocket-plane that they're setting up. So I think we'll be doing that. So I did indeed run up to Knoebels and got to tour around the park as they were making final preparations for their Hollow Fun weekends. They'll be going all through October. Also got to see how they build up these controllers into electrical panels for their use. And the final preparations on the rocket plane to get that ready for opening. It was a good visit, but we need to hit the road to get back to our carnival ride restoration. So if you want to come along for that, click that link to the left and come along for the ride.